This is Mrs. Benke, and these are your instructions for completing the balancing block activity. This new unit that we are studying is about balancing chemical equations. Chemical equations are made up of two parts. We have reactants and we have products. The reactants are what we put into the equation, and the products are what we get out of the equation. We separate our reactants and our products with this arrow, which is called a yield sign. A yield sign is basically like an equal sign in a math equation. The equation that you see in front of you is called a skeleton equation. It's called a skeleton equation because it's not balanced. All it does is show the reactants and the products that are involved in the reaction. When we balance a chemical equation, what we do is we make sure that the number of reactants is equal to the number of products, and we do this by adding coefficients in front of our formulas. And that's what you will be practicing with the balancing block activity using a manipulative where you're building blocks to represent chemical equations. There are several stations available for you to do for this activity. Please make sure that you complete all stations. Take one bag at a time, complete the activity, break apart your work, and then turn it back in and get a new bag. Please make sure that you put all of your answers down on a piece of notebook paper and turn them in. When you get your bag, you're going to notice that there is a tag inside of your bag, a card, and that card has the skeleton equation for what you're going to be working with. And that's where we're going to start. Take the skeleton equation card out of the bag and place it on your lab table. You want to use this as your yield sign, and you're going to want to build your reactants to the left and set your products to the right. The formulas that I have used are made up, but they're pretty simple to follow. The letter corresponds with the color of block in the bag, so P represents purple blocks. Because it says P2, that tells you that you need to have 2 purple blocks. So I take 2 purple blocks out of my bag. But because the 2 is directly attached to the P, that means that my 2 purple blocks need to be attached to each other. So stick your purple blocks together, and you should end up with that. 2 purple blocks stuck together, which is P2. Next, notice that our next formula is Y2. So again, we're going to take out 2 yellow blocks, and because the Y2 is together, we're going to stick our yellow blocks together, which will give us this. So now we have P2 plus Y2. So 2 purple blocks, 2 yellow blocks, but they're stuck to each other. Now we're going to move on to building our product side of the equation. On the product side, we have P2Y. That tells me that I need 2 purple blocks plus 1 yellow block, and I need them to be bonded together to form one common compound. When I do this, I end up with a compound that looks like this. Now I have my basic skeleton equation. P2 plus Y2 yields P2Y. Now I need to start working on balancing my equation. To balance my equation, my goal is to end up with the same number of purple blocks on the left as on the right, and the same number of yellow blocks on the left as on the right. When we look at our skeleton equation, we see that the purple blocks are already balanced. I have 2 on the left and 2 on the right. When I look at my yellow blocks, I notice that they are not balanced. On the left I have 2, but on the right I only have 1. I know that I need to add more yellow blocks on the right side of my equation, but how am I going to do that? We cannot simply add 1 extra block to any side of the equation. It just doesn't work that way. If we need to add more yellow to the right side of the equation, then what I need to do is build another P2Y. So my rule is to add more, I have to add what is already there. When I add another P2Y, I get an equation that looks like this. This gives me 2 yellows to balance out the 2 yellows on the reactant side of my equation. But remember, it also changes my number of purple. Now I have 4 purple blocks on the product side and only 2 purple blocks on the reactant side. I need to finish balancing out my equation by adding more purple blocks to the left. To do that, I'm going to have to build another P2. So now I have a balanced chemical equation because I have 4 purple blocks on the reactant side and 4 purple blocks on the product side. I have 2 yellow blocks on the reactant side and 2 yellow blocks on the product side. If I go back to my skeleton equation, which was P2 plus Y2 yields P2Y, I'm going to use that as the basis for writing my balanced chemical equation. On your worksheet or on your notebook paper, start by writing your skeleton equation. Then what you do is you look at what you built and you fill in with coefficients based on how many sets of each formula you have in your model. So for example, in this case, I have 2 P2s. So I'm going to add the number 2, or the coefficient 2, in front of the P2 in my skeleton equation. I have 1 Y2. I don't use coefficients of 1, so I leave the space in front of the formula Y2 blank. I have 2 P2Ys. So again, I'm going to go back and I'm going to write a coefficient of 2 in front of my formula P2Y. So my final balanced chemical equation is 2P2 plus Y2 yields 2P2Y. This is what I'm looking for on your notebook paper for all of your stations to complete this activity. Please make sure you turn your notebook paper in to the teacher before you leave today.